Hi, welcome back to the next video. In this video, we're going to talk about looping and conditionals. I may have mentioned in the previous video that I was going to talk about slices, but I opted out not to include in this video because it would make it very long, and I feel like I could do a better job of going through it in its own separate video. So I'm going to leave that out for the next video. But yeah, so in this video, we're doing looping and conditionals. So, what is a loop? Well, it pretty much is somewhat self-explanatory. If you have programming experience, you probably know what a loop is, but if you don't, it's continuously executing a block of code as long as some condition is true. You can think of it like this. As an example, say if you were in second grade and you got in trouble for throwing a paper ball across the room, and your teacher tells you that now to write, "I will not throw paper 500 times on the chalkboard." So, going back to the programming sense, you wouldn't want to write 500 print lines of "I will not throw paper." You would just write a for loop that executes that code 500 times. And so that's the power of looping, using loops. And so in Go, we have these three loops here. We have the for loop, the while loop, and the for each loop. These are pretty standard across all programming languages. Maybe not the for each, but so on the right, I have an example of the three types. We have the standard for loop, the while loop, and the for each loop. We're going to code these, so don't get too caught up if you don't write all this down. If you didn't notice, actually, the while loop in Go, we don't use the keyword while. We use for still, but anyway, let's write some code. So I'm going to open Visual Studio and open my Go file. So you're going to need to create a new Go file. I just called my loop condition slice, but we're not going to talk about slices. All of this code is going to be on my GitHub, so it'll be there. So let's start our package main and then our main function. And so for our examples of the three loops in that PowerPoint slide, we're just going to calculate the summation from 0 to 9. So we're going to create a variable called sum with the initial value of 0. And before I go any further, actually, I am not going to reiterate or repeat things that I've already talked about in previous videos because I feel like that's a waste of time. But if it's something that I know I have not mentioned before, then I will explain it. So, moving on, the standard for loop. So, to write a for loop, we write the word for, and then we write our loop counter variable, and it's common to call this variable I in almost every programming language. And we want to start with the count at 0. And we want to sum from 0 to 9, so we keep looping as long as I is less than 10, because we're only summing from 0 to 9. And then we have to increment our variable by 1 every time we execute the code in the for loop. So now we have curly braces, and we write our block of code inside our for loop. And all we have to do is sum is equal to sum plus I. And I will print the value of sum after the for loop is finished executing 10 times. This will calculate. I'm writing all these comments because I'm putting this code on GitHub, so then if you or someone refers to it later, they can quickly identify what's going on. So summation from 0 to 9. Save that, and we will, I'm going to use the command prompt today. So make sure you're in the directory of where you saved your Go file, and then we write go run the file name, and there we go. We got 45 printed because that's the summation from 0 to 9. So for people that don't have any programming experience, how does this work? Well, we said that this was the loop counter variable, and we initialized it to 0. So the variable I at first, has the value of 0. And this is our conditional that we're checking to see if we should execute the code in the for loop or not. And this is what we use to determine how long we should loop for. And since I equals 0 at the moment, and 0 is less than 10, this statement here is true. So we execute the code in the for loop, sum plus equals I, which is sum is equal to sum plus I, and I here is 0. So sum is just 0. And then now we increment our value I by 1. I plus plus is kind of a shorthand for I equals I plus 1. So now I is 1, and 1 is still less than 10, so we execute the code in the for loop again. Sum plus equals I, where I is now 1, so that is sum is equal to sum plus 1, sum being 0, so now 0 plus 1 is 1, so sum is now 1. So we keep doing that until I reaches 10. Once I is 10, we get to the is I less than 10 conditional statement here. And 10 is not less than 10, so that's false, so we do not execute the code in the for loop anymore. The loop is done, and we just print our sum from 0 to 9. And that's why we have 45. And to show that we can do the same calculation using the with the for loop above, but instead of using a for loop, use a while loop. We're going to write that example. So we're going to do the same calculation using a while loop this time. And like I mentioned earlier, Go does not have the while keyword, but it pretty much acts the same way as a while loop in another programming language. So I'm resetting the sum variable back to 0 up here, creating a variable called I, which is going to be our condition to check for our while loop. So for I is less than 10, we want to execute the code. You can think of this as while I is less than 10 if you want, but like I said, there's no while keyword in Go. So for I is less than 10, we do same as above, we execute the same code, sum is plus equals I, or sum is equal to sum plus I. But now we have to manually ourselves write the line of I plus plus to increment our counter here, because instead we wrote it up here. So this is the while loop in Go, and to show you that this will result in the same answer as above, we will print out sum again. As you can see, we get 45 printed twice because it did the same calculation, just two different loops, one using a for loop and one using a while loop. The next loop we have is the for each loop. And the for each loop is pretty much used on looping through a collection of things. And for this collection, we're going to use an array. I know I haven't talked about arrays yet, but in the next video when I go over slices, I will go more into depth with arrays. So pretty much arrays are just sequential blocks, and where each block contains one specific data type. So that might not make sense to you now, especially if you've never programmed before. So just follow through with me for now. It's not too big of a deal. So to do a for each loop, first let's create an array. So this is how you declare and initialize an array in Go. First you want to write the array name. I'm going to call it digits to sum. And then we use these square brackets to declare that this is going to be an array. And inside it, we want to write what our array size should be. And we're summing from 0 to 9, so that's 10 values. I'm going to need 10, array of size 10. So you can think of like 10 blocks next to each other lined up, and each block is going to contain an integer. So that's why I'm writing int. And now I'm going to fill in the values from 0 to 9. If you left this blank, like just empty curly braces, it would just default with every entry being 0. The red squiggly is because I declared and initialized the variable and did not use it. Go flags error for that. So that's what this red line is. We're going to use it momentarily, so it's no big deal. Okay, so this line creates an array of size 10 that holds integers. So you can think of it as 10 blocks next to each other, where each block holds an integer data type. So now we do the for each loop to sum the values here in the array from 0. So we're writing a for each loop to sum the values in this array. Honestly, this could have been in any order, but I just kept it like this. So we gotta reset our sum variable back to 0, and then we write our for each loop here. For each loop. And we do our for I, comma, d for range, digits to sum, and then whatever code we want to execute. And what we're executing is sum plus or equals d, and fmt.println I. So these two variables here, what are they? Well, I represents the index in this collection being 0 to 9, because index 0 is this, index 1 is this, index 2 is this. And then d is the value of the array at a certain index. So let's say I was 5. So at index 5, 0, 1, 2, 3, 4, 5, we have the value 5. So that means d would have the value of 5. So we want to take that value and add it to our sum, which is our summation. And to show you that we still get the correct calculation, I will print out sum again after it's done. After it's done with the for each loop. As you can see, 45 from the for loop, 45 from the while loop, and 45 from the for each loop. This is coming from, so this 0 through 9 is coming from this print here, where I print the index out each time. The good thing about the for each loop is that we don't run into this situation called off by 1 error, which is if I wrote a for loop like the one above here and I just looped it from I to some number. Like what if so I know the array is size 10, but what if I accidentally wrote 9? Well, now you're missing one value, so that's why it's called an off by 1 error. But the for each is nice because it will loop in the range of whatever the collection is. Our collection here being an array called digits to sum. So it'll loop for this range being the size of our array. So it will loop from the beginning of our array all the way to the end. That's what this range is for. So that's nice. So that's the standard for loop, the while loop, and the for each loop. Moving on. Now, let's talk about decision making and the if-else. So, everything we've done so far has been our decision in a sense, and hard-coded kind of. We've never made the code do something based off of a decision. So, if you have programming experience, then you will know all about this. We use it all the time. But if you don't, then stick around And listen up, peers, because this might get confusing. Alright, so the first, very simple, the simplest decision is just an if statement. If something is true, this something as the condition is true, then we do something. And our do something is executing code to do something. So let's take a look at this. This is an if statement, and this is an if-else statement. So this is like a flowchart you can think of as a flowchart. So we have some kind of condition here. And if this condition is true, right here, if this condition is true, this double equals represents an equality check. Single equals is an assignment operator. So that's the difference between double equals and a single equals. But anyway, so if the condition is true, then we execute the code inside our if statement, or our if block, if you want to call it that. But if it's not true, if this condition is not true, then we just go to the next line of code and do not execute this. And as an example, we will write a function that contains an if logic in there. So I don't know about you, but where I'm from, the legal drinking age is 21. So I'm going to create a function called check drinking age, and it's going to take one integer variable a. And so in here, I am just going to first print out the person's age. You are %d years old. Okay, right. Oh, this should be printf. Okay. If you noticed, I'm using printf here and not printline. The printf in Go works pretty much exactly the same as in C. It's a formatted print. So what that means is that you can kind of like substitute things in here. So what this %d is means that you want to replace that with a decimal value, and I'm going to replace that with the value in a. So whatever a is going to replace this %d when it gets printed, and this /n is a regular expression for new line. Okay, you can check the Google Docs on printf if you want more information. Now, this is very simple. Check here. So if the value of a is less than 21, so if a is less than 21, we want to execute some kind of code. So here, I'm just going to execute this print line of no drink for you. Because if the value of a is less than 21, meaning their age is less than 21, they're not legally allowed to drink, at least where I'm from. So we'll print that line of no drink for you. And I'm going to add one line print here just so that it comes out nicely. I'm going to add a comment here. Decision. Ooh, did I spell that wrong? Decision. Okay. Alright, so I'm going to create two variables here. One called my age, set it equal to 24, and another called his age, set that equal to, let's say 19. And then I'm going to pass these two variables into the function that I just created. First with my age, and then the second one with his age. And then we run it. And as you can see, we get these printouts. You are 24 years old, and you are 19 years old, and no drink for you. So let's walk through this. So the first time we called the function of check drinking age, we passed in the variable my age, which has the value of 24. So now we go into the function. It will print this. You are 24 years old, which is right here. And then it goes to this if block here, and we do a check here. Is A less than 21? Here A is equal to 24. So is 24 less than 21? That's false. So we do not execute the code in the if block. We go to the next line of code, which is this print line, which is this line here. Okay, the second time we call the function of check drinking age, we pass in the variable his age, which has the value of 19. So in the function, we print f, you are 19 years old, which is this. And now we go back to the if check here. Is A less than 21? Here A is 19. So is 19 less than 21? That's true. Since that's true, we execute the code inside the if here, and the code to execute is just a print of no drink for you, which is what we get here, and then that's done, and it goes to this line, prints another extra line down here. So that's the simplest decision making you can do, just a simple if. Now we have the if else. So with the if else, if something is true, then we execute some kind of code. Else, we execute some other code, or otherwise, some other code. So, as an example of using if else, we will just add on to our drinking age function here, and we'll just add an else statement. fmt.println, enjoy your drink. And if we rerun it, you can see that now we get these lines printed out. You are 24 years old, enjoy your drink, and you are 19 years old, no drink for you. So, what happened? I added an else statement here. So when I call the function check drinking age, I pass in the variable my age, the value 24 in it. It does the first line, you are 24 years old, which is this, and now it does the if check. Is 24 less than 21? No. So we go to the else block and we execute the code inside the else, which is enjoy your drink, and that's why we get this. And we already went over the situation with 19. So that's if else. So if something is true, do this. Otherwise, do this. That's how you think of it. That's how you can think of it as. Now, moving on, we have the if else. So we have some kind of condition. If the condition is true, we execute this code here. If it's not true, we check the next if condition, the else if. If it's true, then we execute this block of code. If it's not true, then we go to the else, and it just executes the code in the else block. Now, you can have as many else ifs as you want, but to keep this diagram short, I only add one. So, as an example, we will create a new function called check driving privileges. Yeah, so I'll create a new function. Or I'm not gonna call it check driving privileges. Let me just say driving privileges. Driving privileges. I don't even know if I'm spelling privileges right. Privileges. Check driving privilege. And it'll take a integer variable. Okay, so the last time I recalled, which is like maybe 8 years ago, where I'm from, it was 16 years old to get a permit, 17 to get a probationary license, and 18 to get your normal full driver's license. So we're going to use those numbers as our check here, I suppose. So we write if A is greater than or equal to 18. So if you're 18 years old or older, we do this. We'll execute this. And we will just print full driver's license. Else if, or the next, so if you are not 18 or older, we go to the next check here. Else if you are 17 years old, then we will print probationary license. I apologize if I misspell or type anything ahead of time. And then else if A equals 16, then you have permit, so we'll print permit. Otherwise, we will just print not allowed to drive, because at this point, not allowed to drive. Because at this point, you are neither 18 or older, 17 or 16, so you're younger than 16, so you're not allowed to drive. I am going to save that. Okay, so that's our function. Let's walk through it for a second. So if you are 18 or older, we print this, but if you're not, we go to the next else if check to see if you're 17. And if you're 17, so if this is true, then we'll print this. But if it's not true, we'll go to the next else if check. And if you're 16, so if this is true, then we'll print this. And if it's not true, we just go to this. So we will exhaust all possible outcomes here. So I'll create 4 age variables. I'm going to call them H1, H2, H3, and H4. And H1 will be 16, H2 will be 17, H3 will be 18, H4 will be 15. Save that. And then I'll call our driving privilege function 4 times. So this is sort of a pretty good example of using a for loop. So we don't have to write this 4 times, but for simplicity, I'll just do this for now. So let's run our code. Let's see what happens. So we get these 4 printouts: permit, probationary license, full driver's license, and not allowed to drive. And that's correct because age 1 has a value of 16. In our code, if let's just walk through from the beginning. So is 16 greater than or equal to 18? No. Is 16 equal to 17? No. Is 16 equal to 16? Yes. So we print permit, which is what we get here. And that's the same logic for the rest of them, for 17, 18, 15. So that's, excuse me, if, else, if, and else. And now this can quickly get out of hand if you have a lot of else, if lines. Or even if you just want another approach to doing this, there's something called a switch case. And switches are pretty universal and across multiple programming languages, but we're talking about Go here. So in Go, I will show you how to write a switch case. So I'm going to create another function that does exactly the same thing as our driving privilege function, except instead of the if, else, if, else, if, else, I'm going to use a switch case. So I'm going to call our function driving privilege 2 because Go does not support function overloading, so I can't have multiple functions with the same name, which is fine. So you write switch, and then we write our cases. So the first case is if A is greater than or equal to 18. Then we'll do this. Just gonna copy and paste that. Our next case is a equal to 17. We'll print this. And then we have case of a equal to 16. Then we print this. And then the default case, which is the one that gets executed if none of the cases above are ever true. We'll just print this. Okay. Nice. So this here will do exactly the same thing as this up here. So I'm going to call our driving privilege to function 4 times. Take that and run it. As you can see, we get the same printouts, the same 4 printouts: permit, probationary license, full driver's license, and not allowed to drive. So that shows that this switch does the same thing as the if, else up here. How does this work? It's pretty much the same logic. So here we pass in 16, right? So in our switch, we'll check the first case here. Is 16 greater than or equal to 18? No. 16 equal to 17? No. Is 16 equal to 16? Yes. So we execute this print out here, which is why we get permit printed here. And then, for the last one is 15. So go check the first case. Is 15 greater than or equal to 18? Nope. Is 15 equal to 17? Nope. 15 equal to 16? Nope. So we go to the default case. The default case happens when all the cases above are not met. None of the cases above are true. Then it goes to the default case. And if you noticed, in Go, for switch cases, you do not need to have a break statement, which is pretty nice because sometimes I'll forget to write a break and then wonder why certain cases are being executed. So that's nice. You can add it, but it's not necessary. So that's a switch case. That's it's if you wanted to, write it a different way. So now let's go talk about some extra stuff that I did not mention when we're talking about loops. And that's the keywords continue and break. So what does continue mean, or what is continue used for? So continue terminates the current iteration and goes to the next iteration. So let's say your loop loops 500 times and you're on iteration 249 and executes some code. Well, if it hits a continue, then it'll just stop the current iteration. No more code in the for loop gets executed. It'll just start from the next iteration 250. So that's continue. And break is breaking out of the for loop entirely. So going back to the loop of 500, if you hit a break, or if a break line is executed, then you just exit the loop completely and go to the next line of code. So it does not loop anymore. Whereas continue, it just goes to the next iteration of the loop. And as an example of the continue and break keyword, we'll start with continue. We're just going to print out all the even numbers from 0 to 20. So for I equals 0, I is less than or equal to 20, and I plus plus. And so if I modulo 2 equals 0, we want to print that value of I because it's even, because we're only printing even numbers here. Else we will just continue, meaning we don't do anything else, we just go to the next iteration in the loop. And let's execute that. Boom. Wait, where did I write this? Oh, oops, I wrote this in the wrong spot. That makes sense. I meant to write it up here in the main function. Apologies. Let's rerun that. And as you can see, we get only the even numbers printed out from 0 through 20. So how does this work? This operator here is called the modulus operator, and what it does is it gets you the remainder of a division. So if I did 5 modulo 2, you would get 1, because 5 divided by 2 gives you a remainder of 1. And as we know, all even numbers divide by 2 evenly, so we don't get any remainder. So if we divide I by 2 and we do get a remainder, we know the value is I. So let's start at I equals 0, and we loop up to 20. So initially I is 0, so 0 modulo 2 is 0. So we print 0. Now that's done. We go to the next iteration of the loop, I plus plus, so that now I is equal to 1. And 1 is less than or equal to 20, so we go back into the loop. And 1 modulo 2 does not equal 0, it actually equals 1. So we don't execute the code inside the if statement here, we go execute the code in else. And in else we have continue. That just means end the loop now, end the current iteration of the loop, and go to the next iteration. So I plus plus, now I is equal to 2. 2 is less than or equal to 20, so we go back into the for loop. And 2 modulo 2 is equal to 0, so we print the value of 2. And so pretty much we keep going through that logic until we reach I equals to 20. Let's continue, the keyword continue, and now we will go to the keyword of break. And for our example break here, I'm going to write code so that we are always in the loop until we enter a certain number into our keyboard, or enter a certain number from our keyboard. So I'm going to create I'm going to set I to 0 here. Let me see, for I, yeah. So I already declared I above right here, so I'm just going to reset it back to 0. And then I'm going to write for, and if you write nothing in here, no variable, conditional checks or anything, this just loops forever. So it's an infinite loop. And then to read input from the keyboard, you can use the function scan in the FMT package. And if I put 7, then we want to break. And do that print line, exit. So let's look at this line of code we have here. So what do we do in our loop? So this loop loops forever, because there's no conditional here to check to see if we should loop or not, so it just loops forever. And this function here, scan, in the FMT package, reads or you can actually read it right here, but it reads keyboard input, and the value read from the keyboard, the number I enter, will be stored in our variable I. This ampersand here, I'll talk about that in another video. It's actually somewhat complicated. And if we enter the value of 7, then we break and we exit the loop and go to the next line of code. So pretty much we're in here forever, entering numbers through our keyboard until we enter 7. So let's do it. Let's run it. So as you can see, we do not get our current directory line, and it's just blinking because it's waiting for user input from the keyboard. So I'm going to enter 0, and as you can see, we are still in this loop, entering numbers constantly. So what happens is this loop keeps going back to the beginning over and over again because it's an infinite loop and we're never reaching this break statement. So blah, blah, blah. So now if I do enter 7, it exits, as you can see. So it goes up here, reads a input. I typed in 7, so now is I equal to 7? It is, so we reach this break line here. So it breaks out of the for loop, and it goes to the next line of code, which is this print line that prints exit. So to recap this video, we learned about looping in Go, for loop, while loop, for each loop. We learned about decision making through if else, if else, switch cases, and the keyword continue and break. So thanks for watching, and in the next video we will dive into slices.